Hello, good morning, everyone, and good day for those who are in different time zones. My name is Kamesh Namaduri. I'm representing the IEEE Vehicular Technology Society. On behalf of VTS, it's my pleasure to invite Gürkan to give a presentation in the series on the topic of security with relevance to or in the context of advanced air mobility. So Gurkan first of all, is a very good friend of mine, and he is an expert in the domain of security. And we have worked together in many projects, especially IEEE 1920.1 and 1920.2. So here his contributions are immense in this standard, and you're going to see the standard coming up publicly available very soon. So I invite Gurkan to give a talk on this wonderful day, and then I hope I wish everybody enjoyed this presentation, and the presentation will be made available later on the website, so in the IEEE Knowledge Portal. So, thank you, Gurkan, for accepting the invitation. Please proceed.
Thanks, Kamesh, for the nice introduction. So, first, I would like to acknowledge the IEEE Vehicular Technology Society for their sponsorship of this webinar series on advanced air mobility. And thanks for inviting me, especially to organizers, especially you, Kamesh, and also the society. As Kamesh noted, today I'm going to talk about security in UAS networks context, focusing on V2X communications. I'm a senior lecturer at Zurich University of Applied Sciences in Switzerland. So first, a little bit, highlights about myself, let's say. Here I'm a member of the Information Security Group, which is part of Institute of Computer Science. I got my PhD in 2013 in computer engineering from Boğaziçi University in Istanbul, Turkey. Following my PhD, also during my PhD studies, I've been also involved in the industry, for instance, in various R&D projects, Horizon 2020, Horizon Europe, ITEA, Celtic. These are more like big pan-European projects, as well as national R&D projects from InnoSwiss and TÜBİTAK Instruments. And I've served in various capacities, starting like junior researcher, going up to project coordinator, and of course, as an academic consultant. During this journey, let's say, of course, I have published outputs of our research with my colleagues. And also I'm a senior member of IEEE and a member of ACM. Maybe more relevant, apart from my own profile, general profile, more relevant information is, as Kamesh just said, I'm a member of the 1920.2 vehicle-to-vehicle communications for UAS standardization work group, and also IEEE 3349 space system cybersecurity work group. And my research interests are quite broad regarding information security and networks. So it's more like network security. So if you are interested, you can check my profile at my personal academic webpage. So today I will try to cover different things in a limited amount of time in this talk. So I want to give you my key message in advance right now. So once we consider UAS networking security, we have some important drivers, which are also, determining the playground, the challenges, etc. for this topic. First of all, we have vulnerabilities, which are, increasing, let's say, with various complex systems. But at the same time, we have the merger of cyber and physical domains. So if you think about UAS, they are basically, of course, cyber systems, connected, digital, and so on. But at the same time, they are physical systems because they are really working in the physical world. Therefore, you have this kind of positive feedback between vulnerabilities and CPS security issues. At the same time, we have some important characteristics of this domain. First of all, we may have, or we usually have, resource constraints because these are mobile, systems with limited energy resources, computational resources, and so on. And at the same time, these are heterogeneous systems because we have different platforms connected to each other, with different functionalities. When you put all this together, what you have from the cybersecurity perspective is a large attack surface, which makes security challenging. Therefore, in this talk, I will first talk about general security in UAS networks. Then I will try to go over some challenges, and then I will go and discuss what to consider for security solutions. Here, I will not go very specific on this topic. Like I won't specifically take something like a paper, discuss the security solution for anomaly detection, let's say using graph neural networks, whatever. Here, I will just try to put the main important attributes of security solutions for this domain. And I also would like to talk about what we have done in 1920.1 and 2 work groups in terms of our outcomes. So what are the general security aspects when we think about UAS networks? Well, I think it's really important to have this double-sided perspective. We have the physical security issues because since we are talking about cyber-physical systems, these systems are operating in the wild, let's say, Wild West, and they're open to physical manipulations. You can consider this kind of attribute to a data center where you have a much more controlled environment. Of course, we may say in a data center, we have more possibilities for perimeter-based defense, but now we have zero trust and so on, I know. But anyway, compared to such a case, once we consider UAS and their networks, we are more open to the physical world. And these are really use case driven systems. They have this close interaction with the physical world, which brings challenges in terms of physical security, because then you have things like access control, or physical layer security things much more prominent. And then once we look at those systems from the, let's say, connected perspective or digital perspective, what you have is typical cybersecurity problems, and they can be different in terms of their setup. So for instance, when we consider UAS networks, they can of course work in ad hoc mode, right? This may be pure UA to UAS communications. We can have infrastructure-based mode where we have UAS or UAS, multiple UAS connected to a terrestrial network like 5G or in the future 6G or next G networks, or more in a more flexible setting, we can have hybrid mode where we have both, which we consider in our work group activities. And not funnily, but of course, as expected, since UAS systems are these mobile physical systems, which are kind of using especially wireless communications for control, for use case or application data, and so on, they can also become a security threat on their own. So consider cases where you have some UAS, but you lose control and you have different security issues. And moreover, once we consider those systems for many different applications, you start to have more mission critical services. Of course, I am here considering more like, I'm not talking about military systems, they are already there. Maybe they are much more niche, they are very proprietary and so on. But I'm also talking about things like emergency communications, post-disaster communications. Once you have a flood or a big earthquake, these systems are supposed to provide critical services, which make them more important in terms of security. So once you consider this landscape, you have some important challenges against UAS network security. Some of them are old. So there are, of course, cyber threats on CIA triad, confidentiality, integrity, and availability. So yeah, people try to do eavesdropping on your data. They would like to modify your data, forge stuff, or they would like to provide carry out, let's say, denial of service attacks so that the availability is compromised. And of course, we have access control challenges, because these are, again, complex systems with remote access, with different components using each other's services. So we have the access control challenges. And of course, as any typical nowadays, let's say, digital systems, these are software intensive. So we have problems related to software security, and these are like IoT or Internet of Everything devices, because they are part of the internet, they are connected, and they act for different use cases. So once we are, for instance, if you are coming from the IoT security domain, you have similar problems here as well. And if we think about older topic names, which are actually still relevant, like mobile ad hoc network security, there you also have security challenges which are applicable for UAS networks. But of course, there are also some new challenges. For instance, what we call denial of sustainability attacks. So in addition to denial of service attacks, you may try to, for instance, facilitate some attacks which make unnecessary energy consumption on these systems. This is an interesting idea because, for instance, we have route optimization algorithms for some specific applications and so on. Maybe, as an example, you can try to manipulate those algorithms, and therefore you have your UAV doing unnecessary stuff, maybe not very, in a very obvious way, but then it can make your system have more and more resource problems. And once we consider, cryptography, nowadays we have quantum computing becoming more practical. And once we have this, of course, these problems, the problems related to, for instance, public key encryption, like Shor's algorithms impact on current PKE systems and so on, they're also relevant for our networks. And the important topic of AI, the hot topic of AI. And once you go through recent research and development in UAS, you see that there are so many different applications of AI for different purposes. And therefore, once you integrate AI into these systems, of course, there are obvious AI security problems. Finally, let's say, we have three main things related to each other. We have scale, because now these systems are becoming more and more employed, let's say, and they are becoming more omnipresent, because these services, use cases, applications are now ranging from logistics to more mission critical things like military applications or advanced air mobility, let's say. And also these systems are becoming more democratized. When I say democratized, I mean like now these systems can be, acquired by, let's say, ordinary people, and, they can be used, let's say, tinkered for doing different stuff. And for instance, if you have some kind of access to such a platform, even as a script kiddie, which we call, users or people with not much, security information, but they can just run some already available attack scripts, let's say, on some systems. If you have such people with those systems, they can even try to infiltrate and cause problems in UAS networks. And in this context, of course, some problems are magnified. As I told you, physical security is a big problem. You have resource constraints. You may say, what is the relation to security? Well, for any security solution, we always have the problem of overhead, because security is really important, but at the end of the day, it's not part of your core function. Therefore, there is always this kind of, trade-off or challenge of, finding the resources for high security functions. And of course, there is a supply chain security problem, which is becoming more and more problem, not just for UAS networks. This is a common IT thing. You can also think about, what you use in your in your digital hardware, software, third-party libraries, open source software and so on. And once we have this kind of complex system, we have the issue of security management, because usually for doing security management, you need to have power in your system, the right privileges, which means you may be trying to address different systems for security management. And the provision of the power or jurisdiction for those systems are quite complex, and it's also related to business. For instance, if you think about mobile networks, I'm not giving an example from UAS networks, but think about mobile operators. If they are using the same infrastructure, if they are using the same cloud environment, it's quite challenging. Finally, since I would like to make a connection to what we do in 1920 work group, standardization related to, in general, UAS networks, but also security is quite challenging, because here we have the tale, what I call a tale of two cities. Based on my experience, I come from more computer science, electrical engineering background, information security guy. But once you sit down and try to come up with something which is applicable, for instance, for advanced air mobility or some other use cases for applications for UAS, you have this kind of, this is changing, but disjoint view on those systems from the security guys. I'm not talking about safety, I'm talking about security, and the aviation people. So this is something which we need to improve to have more efficient solutions. So if you think about these challenges, what are the core elements for UAS networks security solutions? Again, this is high level presentation. I'm not going to go into very specific solutions, but try to render some guidelines. So first of all, as you might guess, we need to use existing knowledge as much as possible, because as I shown in the previous slide, what we have in terms of challenges are already, some of them are already applicable to existing domains. For instance, we can use tactics, techniques, and procedures which we have developed for IoT networks. An important thing is those security solutions should keep CPS perspective, and they should consider them when they are being designed. And also a practical thing, this is also based on my, let's say, practical experience. We should not let things to be excuses, because once you have practical systems or projects implementing practical systems where you need to have some security functions as well, usually you have things like, we don't have the resources for additional, security functions, or first let's make it running and then we can make it secure. We are very careful about security anyway. Or once you want to have something deployed up and running, then you may have things like, security is frankly not the top priority at this stage. We can think about it later. But this is an important thing, because I will briefly talk about, not briefly, but touch the secure by design approach. This is something which is really important to have secure systems, secure CPS systems, in this case, UAS networks. So what are the specific, let's say, solution approaches in this case after the guidelines? As I told you, we can use something called security by design or secure by design paradigm. This is something we are looking into in IEEE 3394 work group, the other work group I'm involved in, which we basically try to identify core components of a system. So this is more about security systems, secure systems engineering. For instance, if you are thinking about a satellite, you have, the link part, you have the payload. In that payload, you have some specific functions and so on. The idea is you try to identify, deconstruct the system components and see what kind of vulnerabilities, weaknesses are valid. And then you try to come up with countermeasures so that once you are trying to implement such a system, let's say as a company or as a institution, you can use this kind of information to have a secure system by design. So this is something which can also help UAS network security. Also, we need additional security controls or additional layers of security. So we should have, let's say, multiple defense lines for our system. Another problem, which is also challenging for UAS networks in the context of, this mobile heterogeneous systems context, is monitoring and threat awareness. So we need to have better monitoring and threat awareness. So, for instance, a good idea or a good principle is a good decision relies on good data, right? So we need to have, monitoring of our system, and we should be, following threats which are emerging in the internet or in our networks so that we can take action. And for this, an important part of such solutions is dedicated security functions. So this is something which is changing, of course, nowadays. Now we are having more and more, security solutions, specific security functions, but things like security incident and event management systems customized for UAS networks, UAS communications is an interesting idea. And also, once you are having these security controls or security functions, they have to be optimized for resources, because these systems, again, are usually resource constrained, and you would like to do, quite efficient security management and provisioning in these systems. And an important general, in our solution toolbox, an important general approach is, I think, to go for open systems based on standards. So here is a segue to our work in 1920. So if you're interested, for instance, you can check out our work on IEEE 1920.2, also 1.1 standard. I think this is important because the democratization part is related to this. Now we have more available to different users systems, open to different changes systems, let's say the systems which are more kind of flexible. Another big tool in our solution box would be, of course, security testing. So I think this is really important. Maybe this is also something which people from the IT world can help the security of aerial platforms in general, including the things we use for advanced air mobility. This is the idea of having these software-intensive systems. Therefore, you need to have good testing. For instance, for vulnerabilities, or you can just have baseline security testing, right? Here, an interesting research idea, not idea, but topic, because this is already here, is how to use AI. Because once we have these different platforms, UAS platforms, different, let's say, firmware versions, different libraries being used, different hardware components, and so on, how, for instance, can we use AI for large-scale testing? And of course, once we have, again, a lot of decision problems for security, control, and so on, or optimization problems, we may go for smarter systems regarding security. I will talk about LLM or generative AI here, because now everywhere is LLM, right? Anyway, so the idea is AI or machine learning techniques, of course, are helpful, but as I said in my one of my previous slides, their security is also a challenging problem, because you have these systems which are making decisions on your behalf, or doing control, but there you need to be doing robust decisions, or your system should be robust and also perhaps explainable, because at the end people should be able to understand why we have these security related decisions in a UAS network, when we have one UAS being cut out from the network, cut off from the network, and then the system is kind of not usable for our daily applications. Here, cognitive systems is interesting because what I describe here is what we can say like a cognitive system, which monitors the environment, analyzes the data, make decisions, enforces those decisions, again, monitor, optimize, this kind of closed loop. So these are some core elements when we think about network, UAS network solutions, as UAS network security solutions. Now let's try to more focus on advanced air mobility. Because again, I believe these systems, UAS systems, are very, very much driven by applications or use cases. So once you try to consider or identify the security requirement, one important element would be like, what are my application requirements so that I can come up with some security requirements. Here, I'm going to talk about what we have in 1920.2 work. And I would like to briefly describe some specific scenarios or uses. The first one is quite common for advanced air mobility, for general UAS applications, but also for advanced air mobility, of course, collision avoidance. In this use case, basically, we have 2 or more UASs, and they are approaching a region, let's say, at the same time. They need to avoid a potential collision, right? Here, therefore, you need to have some signaling between those UAS, and then they have to have a protocol to decide on, maybe based on priority, who has the right to go, and so on. There is also merging and spacing of traffic. So especially when you have advanced air mobility, you may have structured airspaces or air corridors. These are like, the flying cars in science fiction movies, right? For instance, in Minority Report, you see the cars are kind of in the air, but they follow a structured, let's say, skylanes. So here, the idea is you have these structured air corridors that, for instance, they can start from 150 meters to 1 kilometer in altitude. And then you have to do some kind of, traffic police kind of control. And then you have airborne separation here. The idea is, again, related to controlling trajectory of UAS. So here, in some use cases, in some scenarios, you may need to reroute a UAS because there may be a hazard, regarding your route, and therefore here the idea is you need to kind of provide some kind of information to that UAS so that it will switch to the right route. And also, sorry, there is the airborne separation here. Of course, I think I skipped that. Here, the idea is you just need to keep a safe distance between different UAS. So since you need to have some kind of safe distance between these platforms, you need to have, again, a protocol using usually V2V communications where you need to secure, or not secure, but provision such a distance. And for instance, there is also collaborative sensing of weather conditions. In this use case, we need, again, V2V communications because we would like to, for instance, relay information to another UAS saying that, be careful, here there is some weather hazard for you, so maybe that other UAS may just go back to another route or just land and so on. And this is not exhaustive, right? You can think about different use cases or scenarios where you need to have V2V communications for UAS networks. So once we consider this specific setup, what are the vulnerabilities or what is the security landscape in these systems? First of all, of course, we have some data, critical data, which we need to protect. So we have command and control data. We have navigation, safety-related messages, for instance, for detect and avoid or collision avoidance and so on. But at the same time, consider your laptop. Let's say you have some kind of, so if you have a Windows laptop, you have some antivirus software running on your host, right? So you have some endpoint protection. But for those systems, usually we don't have such entities, such capabilities running. And the thing is, when you are doing security design or security or protection design for such systems, you usually start with some risk analysis or risk-based approach, and these systems can be high risk. And they have also some specific profiles. If you consider small UAVs, you have a different situation where you have more limited resources in terms of energy or computation, which means like your conventional cybersecurity solutions are not always applicable. And you are also running in this IoT world where patching and fixes are not really as rapid as what you have in, for instance, again, in your enterprise laptop. So you have these problems as well. On top of this, these systems can have different hardware and software components. So here we are coming back to the heterogeneity problem, which makes the security landscape more challenging once we consider these specific UAS networks. Well, what kind of, then, I mean, we say we have more, not more, but various vulnerabilities in these systems, but why do we have them? Or what are the critical factors leading to those vulnerabilities? First of all, again, some of these are applicable to general IT systems, but if we focus on UAS, we have this, let's say, inadequate policies and procedures to develop and maintain hardware and software platforms for UAS. So for instance, things like DevSecOps could be interesting to apply, or some new or more security aware practices, processes. Coming back to our comment on endpoint protection or similar solutions, we usually have insufficient defense and security protections, and these are usually still closed systems, and therefore innovation in terms of security is a little bit more challenging compared to open systems based on standards. And we have the inherent usage of remote access, which means we may also have problems with access control policies and authentication. And since we are using wireless communications, we have issues related to wireless communication security. Things, for instance, related to the terrestrial network, because even if we talk about V2V, usually we have some kind of, connectivity to the terrestrial network at one point, which may become an attack vector on its own because of vulnerabilities in, let's say, 5G protocols. And also, the vulnerabilities can be more impactful because usually we don't have a lot of tools to identify anomalous activity. For physical stuff, maybe more, like if you have an abnormal route, a sudden change in your flight and so on, you have the alarms ringing. But in terms of security, there can be things which are running in the background, like advanced persistent threats and so on, which may kind of affect your system, and it may be much more challenging to detect, and we usually have less capability. So once you are trying to analyze the system for security, of course, you also need to have a threat model where you kind of try to identify possible attacks, passive and active attacks. And of course, adversaries also come with different capabilities in this domain. So you may have things like kind of standard spoofing of GPS and remote ID signals. So for instance, in Russian invasion of Ukraine, this is a big problem, not just for the the war theater, but also, for instance, for Europe, because Russians are doing a lot of jamming, not just in Ukraine, but also in Kaliningrad and so on. So it's even affecting the European civil aviation now. So this is also a problem, of course, for security of UAS networks when we consider potential security problems. And also we have jamming. This is another standard problem. We have denial of service attacks, which can be carried out by, or DOST, carried out by attackers. And a typical problem is eavesdropping, because once you want to have confidentiality compromised, you can try different techniques, attacks on cryptographic primitives, key management and so on. And once you can intercept and change such signals, such communications, then you can also compromise the UAS network itself. So this is also one part of your threat model. There's GPS denial, of course, and also an important or a very interesting topic is the attack on components and supply chain compromises. So for instance, think about the latest pager infiltration in Lebanon. So basically what was done was, they controlled the supply chain of those devices and implemented, of course, these are more kinetic attacks, but this can also happen for cyber aspects. For instance, there was this, I don't know if anyone remembers, there was this crypto AG company. Actually, it was a Swiss company, and it was producing a lot of cryptographic hardware for many countries during the, I think, Cold War. And then it was, it was not discovered, but probably after some kind of investigation, it was found that CIA actually owned this company, and they controlled like backdoors and so on, which were integrated into this crypto hardware. So this is a very interesting problem, and for cyber physical systems, this is really important. And we also have lateral movements, which are typical problems for IT systems. So we have, this threat model, we have these potential vulnerabilities, problems in UAS networks, especially for V2E communications. And what are the ways to prevent these threats? So what should be our trust model, security model? Well, again, this comes from our 1920.1 and .2 work. People can come up with different ideas, of course. First of all, we can use mutual entity authentication in our network. I'm focusing on UAS. Of course, again, you have different components. You may have a connection to the terrestrial network, even to a satellite network. I don't know, you have end user devices using your UAS, for instance, if it's acting like a base station as well. But here we are focusing on UAS. So you may have, you can have, let's say, mutual entity authentication. So here the idea is we are trying to follow a zero trust approach. So we basically authenticate between sender and receiver for data origin all the time. And also we can use mutual explicit key agreement authentication. Here the idea is you kind of have the assurance of the key material, or the shared key is only known by the two parties, the sender and receiver. Of course, we need to have confidentiality all around the place, so encrypt everywhere. And also we should have data integrity verification for all the data exchange. Believe me, these are like fundamental things, but in practical implementations of UAS, so many things can be missing. Please don't just think about this very, very advanced, big, high altitude stuff, maybe military applications and so on. Of course, there you have some other certification requirement stuff, but I'm talking about in general. And here data integrity is also really important, because here you should always use in your UAS network authenticated encryption or messaging integrity codes, which will provide you protection against data tampering, forging, at the same time confidentiality. And as a general approach, zero trust architecture is promising to prevent those problems, because here the idea is you always have authorization checked when you are trying to access a resource. It can be anything in your system, any component. But of course, this is easier said than, because that means you have to have additional signaling, additional computation, additional management, and so on. And we should have minimal latency as well, right? So it's not that easy. And a promising additional capability is hardware security, to exploit hardware security. Of course, that means you need to have more advanced UAS platforms. But anyway, if you are talking about like more advanced UAS platform, that's easily feasible. Here, the idea is you use hardware support like trusted execution environments, where you have some hardware secure enclave, which you can use for your crypto primitives or keeping your crypto material so that you are really sure they are really protected. So before my conclusion, I would like to kind of put this together based on what we did in 1920.1 and 1920.2 context. So if you want to put this all together, what you have is like a security management framework. So what can we do in the scope for security management? What you basically have is, you have, of course, a kind of security layer, which will provide you security functions, security capabilities. For instance, you have something like a security orchestrator. It uses data collected from your UAS network nodes. Then probably you have an analytics module, for instance, for anomaly detection, security threat intelligence processing, and so on. And based on this insights, you have some decision module. So for instance, if you have some kind of suspicion about one of those UAS, you may try to take some mitigation actions based on your decision. But how you do this? You need an orchestrator. So you need to have some orchestration so that you can do this kind of security management applied to the whole network. And this should also work together with external security domains, because here we have what we call, again, a multi-domain system. So your system is not just working on its own, but it's also interacting with even cloud services, some control platforms, some other applications which are embedded in terrestrial networks, in some other networks, and so on. So you should also do perhaps this security management in harmony with those systems. But this is not enough, because you need to have the capabilities on your UAS or on your platforms. You need to have, for instance, monitoring agents. Remember my comments about awareness and monitoring. And perhaps to do this, you may need some more clever approaches. You may have a sentinel node, which kind of collects this information and then provides it to your security management. And here you should use the security capabilities which I mentioned, like authenticated encryption or hardware security all around the system. So once you can put this together, then hopefully you may have a more secure UAS network. So I would like to thank you for listening. So coming back to my key message, yeah, we have vulnerabilities, various vulnerabilities in UAS networks, especially in V2E mode. We have cyber physical system security issues, but at the same time, we are constrained by resources and challenged by heterogeneity. And then we have a large attack surface. So we have to be creative and persistent about creating secure systems in this domain. Thank you. So I would love to answer any questions or discuss any comments.
Yeah, thank you, Gürkan, for a wonderful presentation. I think you summarized the key elements of US security very clearly and succinctly. At this point, why you can unmute and ask questions. And in the meantime, I will be asking some questions unless I see something uh, from the participants. So you can just unmute and talk, or you can just type it in the chat message. So Gurkan, my question, one central question I always had with respect to UAS is that given this very high mobility and things can the things network can be easily disconnected, meaning that a drone, a particular UAS, may be out of range or maybe some due to antenna position or when it is turning around, it's possible and highly likely that a node may be disconnected. So given this, what are the methods that we could try to come up with to come up with better security, meaning lightweight solutions, um, but at the same time real time. For example, the delay tolerant networking is another option in some cases, but here we always need we always need to be in touch with the UAS and also authenticate. There are many aspects, of course. So how do we manage this? How do we handle this? The impact of mobility on UAS networks.
Yeah, this is a big challenge, right? So this is related to my physical aspects of UAS networking comments. So yeah, this is a big challenge. Here there are things which can be utilized, for instance, which is already being done in terms of edge computing, offloading, store and forward approaches, or delay tolerant networking. Or maybe instead of having some of the functionalities which I mentioned centrally, like you have this aggregator and doing decisions and then sending them back to your network nodes, which may not be feasible, as you just mentioned, in your environment, then maybe you can try to kind of have a more distributed approach. So here you have to be smart. For instance, the Sentinel node, which I showed in my slide, can have different levels of capabilities. Of course, again, if a device is totally disconnected, then it's on its own. But at least if you have a more distributed architecture, for instance, again, coming back to this more capable UAS idea, you can have some of those functionalities embedded on those mobile platforms. But this is an optimization problem, honestly. So you have some constraints, some kind of actual situations where you need to optimize your security functions in terms of their distribution and in terms of their signaling. But yeah, I mean, the solution needs to have multiple things working together. Like, yeah, so if you have intermittent connectivity, maybe you can switch to a mode where you can do more simpler. If you are talking about anomaly detection, much simpler algorithms running on the system. But once you are connected, you can just go on streaming your monitoring data to the central entity and enjoy more sophisticated security intelligence and so on. But of course, at the end, you may suffer in terms of your security level. But again, these systems are running in the real world, so they are not like connected to the network and also to the power with cables.
Is there a way to resume a process that is ongoing? Let's say you are in the middle of some authentication process, or where you're verifying something, but in the middle the network is disconnected. Is there a technique, or are there any techniques to resume the process? That way you don't have to restart the whole process again. Are such available?
Yeah, actually, in some authentication protocols, you may do some pre-computation and provide, let's say, some tokens to systems. Therefore, if you have high delay, like a satellite network or some connectivity problems, you can still go on with your authentication protocol, or at least make it simpler. So there are, of course, these optimizations for authentication protocols. But at the end, again, for authentication, yeah, but if you have an incident, let's say, if you are not connected, then you cannot really mitigate, perhaps. Of course, the platform itself can be self-healing. That's what I was kind of referring with endpoint protection. But at the end, it's definitely more challenging, even though you may do some smart stuff to optimizations in terms of protocols, whether rather smart, whether for authentication, for encryption, or some other stuff.
Okay. Yeah. No, again, please just type something on the chat message, or you can even open, just freely talk. But I have a few more questions, while I'm here. If I see something, I'll stop and give preference to questions from the participants. The other question I had is, let's what you call accept the fact that a purely ad hoc network only in the airspace probably is nearly impossible. Meaning that there should be some sort of a infrastructure that at least some nodes are connected to the ground, or maybe to satellite, or maybe to cell tower. That way there is some sort of a stability in the network. So even in terms of security solutions, it goes to you can take any one example, whether it is authentication, or maybe is it it could be probably a confidentiality, or you're verifying the integrity. So whatever be the process, we can assuming that there are some nodes which are connected to the ground or to the satellite to provide the backbone. So something like semi ad hoc, or partially ad hoc and partially infrastructure. So would that help to come up with it's a security solution that is suitable for UAS? So what I mean is that, okay, well, there is this mobility. Let's take it for granted. There is this pure ad hoc network have all connections and disconnection, so it's clearly unstable. So let's bring some sort of stability to the network by assuming some links, some links to the ground or to the infrastructure, to the satellite. Do we need to come up with the new solutions, or do we have any solutions at this point that can take advantage of a weak connectivity to the ground or infrastructure?
Yeah, this multi-mode connectivity is something which is definitely, I will not say promising, but which is already available, because we already have this. And definitely the already available security, not security, but let's say networking protocols or technologies, let's say 802.11, you have 5G, or now you have beyond 5G systems being discussed, and so on. They are, of course, a part of your solution. Here, as long as you have more flexibility, this can be in terms of connectivity. It can be in terms of your platform's diversity. So maybe one platform can do a lot of stuff for security. So if you have such a platform in your system, then you can offload stuff to that platform, and that can maybe offload it to a central entity, terrestrial entity. This is also relevant for connectivity. You can do things in V2V mode, or if you feel like you have a good connectivity with less, let's say, energy overhead, then you can just pass it over instead of doing relaying and so on. So these fundamental communication flexibility or optimizations are definitely, because at the end these are wireless systems. So you need to do data exchange. You need to do some kind of maybe UAS to UAS, maybe UAS to terrestrial, UAS to, I don't know, another aerial network or space network, data exchange. So this is, of course, a part of the solution. But here you don't need to come up with, you don't have to reinvent the wheel. So you can use existing wireless network standards, which are, of course, if they are available in your system, for these purposes. If you think about, of course, I'm talking about advanced air mobility, but if you think about more niche applications of UAS, like military applications, of course, they have their Link 16 or different, wireless connectivity systems anyway. So I don't know their details, but then they can also use this stuff.
Yeah, thank you. There is one question from Srijit. He says, I was wondering if there is an efficient way to handle GPS denied environments for UAV, UAM applications. He's asking about GPS.
I'm not a signal processing guy, but I know there are, you need to go hard for hardware, So the idea is there are different GPS receiver IC or components which are using different signal processing and antenna techniques, allowing you to have better reception for the for the benign or for the actual signals. Or then you can also do, of course, data fusion in addition to GPS for geolocation or for other kind of spatial, geographical stuff. You can use different sensors, like you can even use terrain mapping or use some signal sources around to identify at least your your location. But at the end, if you have a huge signal suppressing your GPS signal, and if you are not ready for it, if you just rely on GPS, of course, think about your navigation system. So it has that reckoning, right? If you lose the GPS signal based on your previous route in your car, it will just assume some kind of trajectory, and it will just try to follow the map and based on your previous speed and so on. So there are some, of course, smart approaches using different techniques, merging data from different sensors, and also the GPS receiver itself with multiple antennas. Of course, you can use different GPS systems like GLONASS, GPS, and what was our system, Galileo, and so on. But again, this is you can do physical layer mambo jumbo. Again, I'm not a signal processing guy, but this is a general problem.
Yes, it is true. It's a general problem. So Srijit, I think you can, if you want, you can unmute and ask further question.
Thank you, Dr. Kamesh, and thanks for the answer. But so one of the problem we work with is like the GPS denied environment when it comes to jamming, and we usually look into the DOP values, dilution of precision values, and do the operation. One of the thing is like when it comes to beyond visual line of sight operations, as well as the AM vehicle in future. When controlled by a remote pilot or something, that's one of the problem. We feel like need to be addressed at some point. Thank you again. Thank you so much.
So Srijit, actually, as Dr. Gürkan got suggested, it's more general problem. Of course, security is connected to that, very well connected. We can reach out to us offline.
It's a safety problem as well, right? So
Sure. Thank you so much.
Thanks.
All right. 1 more minute for any further questions. Otherwise, thanks, Gürkan, for a wonderful presentation. It is definitely it's a new field in the sense you cannot just take everything that you have in the terrestrial security framework and apply, and it has to be looked in a new dimension and from fresh eyes, and the challenges are significant, and I think your presentation is definitely your presentation is giving give a big picture as well as the issues that we need to look into further. Thank you so much.
Yeah, I mean, I didn't say it, but as you say, this application, air mobility, is much more regulated. So we are not talking about not being able to access your mail server for a few minutes. We are talking about, systems carrying passengers and so on. So security and safety are much more stringent, or the expectations requirements are much more stringent. So I didn't talk about this, but this is another aspect. Thanks a lot, Kamesh. Thanks for listening. Everyone.
Yeah. Thank you all. Please join the IEEE VTS Society or Vehicular Technology Society. Information is available on this slide. Also, I shared a link, the information about not only this seminar, which will be made available in few days, but there are also past seminars that you can access. And this series is going to continue in 2024 and 25 as well. So please sign up and attend these webinars at your convenience. And thank you again for all of us. Have a wonderful day, a wonderful week. Best wishes. Thank you.
Thanks. Thank you very much.
Okay.
Bye-bye.